So we've been looking at doing summations of geometric series, and we've started talking about the finite ones. Today we're going to start looking at the infinite ones. So this is the last formula that you need to add to your green sheet. Make sure in the box that you write the word infinite. All right, and this is the formula you need to put down. Put parentheses around the denominator. All right, it says the terms of a geometric series grow rapidly when the common ratio is greater than 1. All right, in other words, if we're multiplying by things like 2, 3, 4, the summation is going to grow very quickly. Okay. Likewise, they diminish rapidly when the common ratio is something between 0 and 1. Picture taking a quantity and cutting it in half, and then cutting that in half, and then cutting that in half. All right, it's going to get smaller and smaller and smaller. In fact, they diminish so rapidly that an infinite geometric series can have a finite sum. All right, so I want you to picture if I gave you the series 1, 4, 16, 64, etc. What am I doing? I'm multiplying by 4. Okay? What would the next number be? $256. Would that change the sum? In other words, if I added these numbers up, would my answer change when I add in the next number? Yes, because that next number keeps getting bigger and bigger and bigger. In that situation, we cannot find the sum. Right? If our numbers are going to keep getting bigger, the sum would keep getting bigger. So we are looking specifically at values that have a common ratio less than 1. Its absolute value has to be less than 1. Another way of saying that is your R value has to be less than 1 but bigger than -1. So we're looking at things like 1/2, 2/3, -3/4. Okay, something between -1 and +1. Those R values will make our numbers get smaller, and then we can find the sum. Okay? There are two terms, converge and diverge. If we can find the sum, in other words, if that R value is something between -1 and +1, then we say the sequence converges. Okay? We start adding those pieces together, but the next piece in line is so much smaller that it's not really going to change our total. Does that make sense? Okay. If we can't find the sum, like in the example here, I would say that sequence diverges, so there is no sum. All right? So if you have an infinite geometric sequence, you can only find the sum if the R value is between -1 and +1. Okay? So I want you to put on your green sheet that formula, but also make sure you have the word infinite. Make sure you have this restriction about R listed in there, because we do have to consider those infinite ones. Some of them won't work. All right, so for the first one, are my numbers getting smaller as I go? All right, that means I am dividing by something as opposed to multiplying, or I'm multiplying by a fraction. Does that make sense? All right, how do I find my R value? In any geometric sequence, how can we figure out R? Give me the formula we use. Okay, we need to take a term divided by the one in front of it. So second term divided by first term. All right, in this case, 1/2 divided by 1, right? And our fraction's fairly obvious. You looked at that and could tell we were multiplying by 1/2. But it won't always be that obvious, right? So just remember that you can divide the second term by the first term to figure it out. Since R is something between -1 and +1, we would say this converges, and we are able to find the sum. Our formula for this is our most basic formula of all the ones we've been looking at in this chapter. First term divided by the quantity 1 minus R. Do we know the first term? Yes. Do we know R? Yes. Notice that there is no subscript here. When we did the finite ones yesterday, we had things like S sub 11, finding the sum of the first 11 terms. Okay? When there's no subscript, that's the hint to you that this is infinite. All right? There's no set number of terms that we're adding up. There's an infinite number. Okay? So when you're sorting your formulas, keep that in mind. Okay? No little subscript. That's your infinite one. All right, so first term was 1. Our R value is 1/2. You should not need a calculator to do this. What's 1 minus 1/2? 1/2. What's 1 divided by 1/2? Dividing by 1/2 is the same as multiplying by 2. So we get a sum of 2. All right. Our next question. Does it look geometric? The formula? Okay. It's an exponential one, right? The exponent is your variable. So that means it's a geometric sequence. It's infinite because of that little infinity symbol there. Okay, so we're looking at an infinite geometric sequence. What is the R value? What's the piece that's being raised to the power? -5/4. Is that within the range that we can have? No. All right, so we would say this diverges, which means there's no sum. Our next example may not be as obvious what we're multiplying by, so let's go ahead and figure it out. We take our second term and we divide by our first term. Dividing by 1/2 is the same as multiplying by 2. So this would be 3/4 times 2, which would be 3/2. 6/4, which reduces to 3/2. Is 3/2 within the range that we can have between -1 and +1? No, it's too big. This is another one where we say it diverges, so there is no sum. Okay? We can also tell our numbers are getting bigger, right? 1/2, 3/4, 9/8. Those numbers are getting bigger. All right, so if I'm picturing going to infinity, then the last number in that list is going to be huge, right? It's going to change my sum. All right. Are my numbers getting bigger or smaller on this one? 1/3, 1/9, 1/27, 1/81. They're getting smaller? Okay, so let's figure out what our R value is. We have -1/9 and we're dividing by 1/3. Dividing by 1/3 is the same as? All right, -1/9 times 3. -3/9 would be -1/3. So our R value is fine. It's between -1 and +1. Okay. So we can find the sum. We need our first term, which is 1/3, and we're dividing by 1 minus -1/3. Again, we should be able to do this without a calculator. What's 1 minus -1/3? 1 plus 1/3, which would be 4/3. So we have 1/3 divided by 4/3. Okay. 1/3 times reciprocal, 3/4, gets us 1/4. So they're saying if I take 1/3 minus 1/9 plus 1/27 minus 1/81, if I keep that pattern going, it's going to simplify down to 1/4. All right. Next question. It is infinite again because of that infinity symbol. Is it geometric? Okay. It has a variable as a power. What is my R value? The 2/3. So is this a question where I can find the sum? All right. So we say it converges. So I'm going to be able to figure out the sum. In order to do that, I have to know my first term. So my first term is whatever I get when I plug this first number in. So I'm plugging a 1 in for n, 2/3 to the first power, 2/3. So my first term is 2/3. My R value is also 2/3. So when I do the summation, I have first term divided by 1 minus R. What's 1 minus 2/3? What's 2/3 divided by 1/3? 2/3 times 3. 2. Okay? Questions on using that infinite one? All right. So homework for this is 9.5b. You are also expected to do the formative quiz for 9.4. I will get that open for you in just a second. If you have not done the 9.1 to 9.3 formative, I will be talking with you today. Correction, our assignment is page 599, 19 to 31, 38, 41 to 45, and 47.